There is another very useful population technique for zones that I want to show you right now. And this technique can actually be used for another thing, which is removing some of the areas of the terrain. If you remember, with one of the renders we had a kind of a spiky point sticking out. This method can be used to also remove that little spiky area. But first, let's take a look at this technique to control the ecosystem population and setting up a different type of zone, one that will work better when you don't want to resize the terrain, and allow you to, in this case, pick out a zone within our defined terrain zone. And it takes a little bit of setup, and I already have a scene created with it set up, although it's not this scene, but it'll give you a good idea of what it is we're going to be doing while we're setting it up. So I'm going to save this scene as it is right now so we can come back to it and go ahead and open the tooth connector scene, which is in the primary directory. What this is, if we take a look, I have a sphere connected to the tooth Gaussian fractal, or noise assigned to a fractal, and its scale of the fractal applied to this sphere. So what we can do is increase the size of the sphere to increase the tooth Gaussian fractal. If I scale it down, we can see that change, and the origin is also connected, so we can move around that fractal as well. And now I have this assigned to a color map, black and white, to really show what it looks like. So what we have is a simple fractal, and I'm going to be going over the settings within the other scene, but we're just connected to the size and position of the tooth controller, which is the sphere. And this way, if we go ahead and just create a quick render, we can define which areas of the population we'd like to show up by moving a sphere around within the object. So now if we move this sphere over to the side, we'll go ahead and scale it up, and I'm going to re-render that, and now we can see that moving. So it's a new way to define our population zones. And the way this would work for removing points of the terrain is to give the tooth a reverse function. In other words, to subtract from the terrain within the range defined by the sphere. Now the roughness setting and the gain would have to be adjusted to smooth out the edges and the Gaussian part of the noise, but it can be used as a very, very useful tool. So I have loaded in Landscape C12 EcoPop, which is the last scene we were working on before we took a look at the connection between the tooth Gaussian fractal to control our color in the other scene. So now we want to create the same setup to be able to define a zone within our current landscape zone. So we're creating a population zone within our overall landscape. And this can be used with different objects for each layer, but you will have to set this up for every layer. Once the initial setup is created, you can then create a meta node and then really easily and quickly take care of that. I'm going to select our landscape and its material, and for the ecosystem I'm going to turn off full quality near camera just because I am going to be moving around the camera, or might be moving around the camera, and just in case I don't want any refresh lag. So with that off, and now with the landscape selected, I'm going to create a sphere. And because the landscape selected, it's going to apply the material to our sphere. And because we have an ecosystem, it's going to ask if we'd like to populate it. So I'm going to select no. I'm going to reset the material for the sphere, edit the material, and rename it Tooth Controller Ecozone. We can then reset the color map, edit the color, and basically give it whatever color we want to show up within the scene. I'm going to make it green since we're controlling an ecosystem zone. And I'm going to hide it from the render. Make sure it's not part of the G buffer. Make sure it is not affecting our decay near foreign objects. And ignore indirect lighting. Even though it's not rendering, we still want to do that just in case. I'm going to hide the main camera right now. And I'm going to rename this sphere Ecozone 1. Now as you can see, we can't see the sphere because our scale isn't set large enough. The reason I did select the landscape first was just so when our sphere was created, it would match the origin or position of the selected object. And now I'm going to switch to the scale gizmo and increase the size of our sphere so that we can see it. And just position it a little. Keeping in mind that when we populate the ecosystem, if the sphere is intersecting with the landscape, we won't be able to see the ecosystem. Right now I'm just using it as a reference, and I will be moving the sphere around either above the terrain or below it. What we could also do is set up a bit of transparency in order to be able to see through it if you want to have that intersection. So I'll just do that right now. We can open the material and set a global transparency of 50. So now we'll be able to see through the sphere and take a look at the ecosystem. So if you want to do that, you can set up that transparency option as well. If you have transparency options available, depending on the video card and display settings you're using. So let's go into our landscape zone and landscape object, edit the material. And since we're working with the first layer, we're going to go to the Density tab, and under Variable Density, right mouse click, edit the function. And what we need to do is create that setup. Also keeping in mind that we have the world standard mode set, a scale of 1, and that is going to be really important. Also, our function scale is set to 1 within the material editor, and which is another reason why I like to keep our scale set to 1, just because I do like to connect things to objects in the scene, and rather than having to reconfigure each individual material and make that connection, it's just easier to set it to 1. Although, if you do own the MetaTools collection, there are tools available that allow you to change the material scale when you're linking objects, and primarily that's with the image plane or object plane control for controlling images and links within materials. And I'm going to show two different methods of creating this, one for users of the Meta Tool collection, or the Meta Node collection version 1, and for those of you that don't have it, I'm also going to set up that version as well. So let's start out first by creating our fractal. So we're using a simple fractal. We're going to go to Noise and change this to Math Patterns Tooth Gaussian. Now we want to control the largest feature with the size of our Ecozone 1 sphere. In order for that to match up correctly, we need to set the wavelength to 2. I'm also going to adjust the roughness and gain setting. And I'm going to set the roughness to 0.4 and the gain to 0.2. I might need to reverse those depending on how it ends up looking, but we'll go ahead and start with that. Go ahead and move this off to the side. Now we need to add in our right mouse click, input node, external dependency. And I'm going to go ahead and do that again. One for our position and one for our size. Our dependency, zone 1 size for our right, and the position for the left one. Just to make a reference, we'll call the position 1 position and the size size. And that'll just make it easier for us to know what's going on. So what we can do is disconnect or extract the largest feature option. And now we can't just directly connect this to size, because our size is a vector. And depending on the internal unit you're using, that vector value is going to change. Whether you're using the MetaTool or MetaNode collection, or you don't own the collection, you're going to need to add in a math node, vector operation, and decomposer 3. If you are using the MetaNode collection, what you can do is add in, and I just have all of those nodes in my Fractal node MetaNode folder just to make it easier to access. You can use the internal unit vector correction between size and the decomposer, and the internal unit of the scene is 0.1, and that will automatically set the scale to whichever axis you'd like to use. I'm just going to use the X because I'm not going to be changing the scale on the Z or Y, and I'm going to keep it a perfect sphere and not change the scale of that at all and keep it proportionate. Now, if you're not using or you do not own the MetaNode collection, this node itself is really fairly simple, although it does convert every single vector and a connection to the vector. If you don't own the collection, I'll go ahead and delete that. What we can do is create a blender between the link, our combiner node. Because the meta node was selected last, we need to set that to blender. Actually, we'll go ahead and we're going to be changing that to multiply. So now we can take our number input, connect it to multiply, select that X once again, and we have that constant number from the extraction. We can use that, keeping in mind, because we extracted the largest feature option, it is giving us a slider for the largest feature control, and it's not a typical constant number, not the one we would normally get. So if you're designing your own meta nodes, that's a really easy way to get the slider option, since you can't just create your own. I am going to change this to a constant number, the default one, where we type in a value. I'm going to type in 0.1, which is our internal unit, and we can multiply the X vector by the internal unit in order to get the scale to control the fractal correctly. And that's because I'm using a wavelength of 2. Depending on the wavelength you're using, there are ways where you wouldn't have to change that. But I just found this to be a pretty easy method. And now what we need to do is just connect the origin to our position of the sphere, but we don't want the Z to be part of that, just in case the Z position is going to affect the noise. And I'm not sure whether or not the Gaussian is a three-dimensional fractal or if it's just X and Y value. So just to be on the safe side, I'm going to create the same sort of connection and the exact same node we use to make the Zone 1 control. It's exactly the same, and the same sort of an idea. What we can do is add math node, vector operation, create our composer, math node, vector operation, decomposer 3, create another decomposer 3, and we're going to connect the X and the Y for input 0 and input 1. Input 3 will be connected to the Z, so we can connect that Z to the position of the material, the X and the Y to the position of our sphere, and extract the origin and connect that to the composer 3. So now it is going to line up perfectly with where the location of our sphere is, provided once again that your scale is set to 1 for the material scale and you're using the world mode. Now if you own the MetaTools collection, and I've also included this node along with the training, and this is the vector XY Z constraint, which is the same one we basically made before. Now the difference with the version I'm using, it has a direction to input and output. I'm just going to go ahead and disconnect the origin first and delete these nodes. And now if you're using this node, we can connect the origin to the vector XYZ because we're traveling to the direction of the output. XY to the sphere, Z to the position of the material. And that's if you're using the MetaNode collection version 1.0. At least the asileFX MetaNode collection version 1.0. Whether or not there are others, I'm not sure. And because we're working with pure origin, we're not converting it to a number, we don't need to worry about the internal unit. So right now we don't have it connected. Just to test and make sure, I'm going to connect that to the altitude. Click OK, and we can repopulate. And we can see a density, full density, within the sphere area. Now, what we're seeing on the outside is part of the Gaussian. We're going to have a bit of a fall off. Personally, I want that. Just because if I want to use this to subtract from the ecosystem or to add in to the current distribution in an area that I think should have population, I don't want it to be a really, really harsh blend or a harsh line for the population. And that way it would look exactly like a sphere. So with the Gaussian, we can go outside of the zone a little bit. But right now this is just specifically the tooth Gaussian distribution. In order to connect it to our current density, making sure we go to layer 1, we need to create a blender, connect our density to the blender. Our first input, go ahead and zoom in so you can see a little better. Input 0 to our current density, input 1 to the tooth Gaussian we just set up. And now we need to set the mode to minimum, min, and the ratio to 1. And what that's going to do is subtract everything outside of the Gaussian, but keep the information we have from the terrain noise. Now we can repopulate and see our current distribution within the zone we just created, and the sphere zone. And then we can move that around, scale it, change it in order to pick out different ecosystem zones. So now we can see we have the Gaussian, and now that Gaussian setting, if you want to reduce it, what you can do is adjust, and we got to make sure we go to that first layer we're working on. We can increase the gain, and that will reduce the amount of fall off around the end. I'm going to go ahead and switch these two, change the roughness to 0.2, the gain to 4, repopulate, and we can take a look and see how that's showing up. And it looks like that may have increased it. Because we're using a fractal, the Gaussian can be a little unpredictable with the roughness setting. So I'm going to change our roughness back to 0.4. And it really might just be a matter of adjusting the gain, whether or not you want to do this outside of the current scene. Maybe you could load in the tooth Gaussian scene to get your settings the way you want them to be. You could even do a test distribution or a test population with any ecosystem in order to set it up. If you're working with, in this case, we have a lot of vegetation, and if you're working with a large area, it can take a longer time to populate that. I'm going to keep the gain at 0.4, see how that is, just repopulate it once again, and see if that maybe restricts the zone by changing the roughness amount. And it looks like it primarily was the roughness that was going outside of it. So if you want to constrict it a little bit more, you can increase the gain, because with the fractal setup with the tooth Gaussian, what it is almost another type of gain, because it actually doesn't create any sort of rough areas within the node. So if you wanted to adjust the eco zone, maybe make it a little bigger, move the position, and I'm going to see if the OpenGL will recognize a higher transparency amount, and it does. So this way we could see the ecosystem a little bit better through the controller. Go back to the landscape, layer 1, repopulate that. And now we can see that new area. So now within our overall zone, we can define a new zone by using a pure fractal or pure procedural instead of using an image. You can set up an image if you want to really define those areas, maybe by painting them, creating a render from the top view, and really figuring out exactly where you want certain things to go. Then you could position, and what you'd want to do in that case is use a box to represent the scale of the texture. Or if you own the metanode collection, you can use the object plane texture converter, which will basically convert the image plane size to a texture size to match correctly, because object planes have a little bit of a different coordinate system for scale, because they have no z-axis, and that does kind of mess with everything. So that conversion is already set up within that node, and that way you could even use that image plane to preview the texture itself that you've created for the distribution and place it over it and really get some nice control that way. Another really nice thing about this is we could set up different zones for each ecosystem layer. So if you only want to look at a small zone of a specific layer, then you could set this up just as we have for one layer. But if you want to create an overall population, so we'll go ahead and just do that right now with something simple. Go to our second layer and add in one of our plants. We're going to select maple number 2. Load that in and populate this current distribution. And now we can see layer 2 showing up, but define how we want to see the first layer. So in this case, we don't have any intersection. So let's go ahead and take our eco zone and just move that over into this part of the population. And let's populate our first layer so we can see the interaction of just layer 1 within layer 2. Go ahead and repopulate that. And now we can see the layer 1 population controlled by our zone within layer 2. So layer 2 is staying consistent, but we can fine-tune a specific layer. So you could set up multiple zones using these spheres to work within another zone. And this is just a really, really easy way to once again be able to preview by using actual population rather than just setting it to dynamic population, which doesn't give you an OpenGL preview. But this way, when you do switch it over to dynamic pop with the overall scene and the overall landscape, you know what it's going to look like ahead of time. And I'm going to go ahead and just save this out as number 13.